Now we're going to look at the representation of the roots of quadratic equations graphically, or the identification of the roots of quadratic equations by looking at the graphs, by an inspection of the graphs. What are roots? We've dealt with this in a previous video, but I'm just going to remind you. For a quadratic equation of the form y equals ax squared plus bx plus c, where a is not 0, a, b, and c are constants, and a is not 0, x and y are variables, the solution to the equation ax squared plus bx plus c equals 0, i.e. the solution to the case where y is 0, or the solutions rather, are the roots of the equation. Remember, we solve quadratic equations like this using methods like the method of completing the square, that should ring a bell, or the quadratic formula, also known as the almighty formula, or even the method of inspection. Solving equations like this gives rise to the roots. So for this equation, the root is the solution of the case where y is 0, this equation. Now, I'll give you an example. So the equation y equals x squared. The roots of this equation can be determined analytically. And what do I mean by that? Just by a straightforward procedure that will give an exact answer. So what's the root of this quadratic equation? Well, let's replace y with 0. We get 0 is x squared. X squared equals 0. Now, I'm not even going to bother using the method of inspection or completing the square or quadratic formula here, because x squared equals 0 is the same thing as x times x equals 0. And remember, when you have the product of two variables equaling 0, the solution to such a case is the case where either of the variables are equal to 0. So x is 0 or x is equal to 0. So in this equation, the roots are x equals 0 and x equals 0. So the roots are the same, so we just have one root. We have what is known as a repeated root, so x is equal to 0. So the root of the equation y equals x squared, or the root in this case, is x equals 0. Now I'm telling you that instead of using this analytical approach, by the way, you could have applied the quadratic formula to this, or the method of completing the square, or the method of inspection, and you will get the same answer. So where I'm heading is that instead of using this analytical method, so this method that gives an exact answer, we can use a graph. Now we plotted the graph of y equals x squared. Now I gave you a rough sketch. This is a neater graph here, and remember I told you quadratic graphs have shapes, U shapes like this or N shapes like this, and these shapes are known as parabolas. This is a parabola, this is another parabola. So how do you identify the roots from the graph? Well, the root of a quadratic graph can be identified by looking at the intersection of the quadratic graph with the x-axis. So this is a graph. This red line is the quadratic graph. Is the plot of y equals x squared. The x-axis is this horizontal line in black. Now their intersection gives a point. The x-coordinate of the point of the intersection is the root in this case. This point where they intersect, so you can see this black line and this curved quadratic curve. They intersect here at the origin. The origin has coordinates 0, 0. The x-coordinate is 0. Now I'm telling you that the root of this quadratic graph is the x-coordinate of its intersection with the x-axis. So I'm going to write that. Root graphically is the x-coordinate of intersection of the graph and the x-axis. So don't forget that. Here's another quadratic equation. The equation y equals minus x squared plus 6x plus 9. I can simplify this to give, so I multiply through by, well, this is a minus 1. Minus you can treat as minus 1. So multiplying through by minus 1. Dropping in brackets gives minus x squared minus 6x minus 9. But I'm just going to keep this bracketed version here. This graph, the red line, is a plot of this quadratic equation. As you can see, it has the parabolic shape. Now, in order to determine its roots, analytically, you would replace the y value, this y variable, with 0. And you solve the equation you obtained. So 0 equals minus x squared plus 6x plus 9. If you solve this equation, you get the roots. The roots are x values, the values of x that satisfy this equation. So let me multiply through by minus 1 to just simplify this. Minus 1 times 0 is 0. Minus 1 times this gives x squared plus 6x plus 9. Minus 1 times this minus 1 here is plus. So the minus sign just goes. Or you can think of it a different way. Minus times minus is plus. Minus 1 times 0 is 0. Or minus times 0 is 0. You can think of it either way. Anyway, this is the equation you have when we replace y with 0 here. X squared plus 6x plus 9 equals 0. This equation can be solved using the method of completing the square, or the almighty formula, or the method of inspection. Now that could potentially be a long procedure, but we're going to try, let's try the quadratic formula here. Or even better still, let's use the method of inspection. So I'm just going to do it quickly. Now, solution to this is x plus 3 equals 0, or x plus 3 equals 0. Remember, when you have an equation that states that the product of two variables is 0, the solution to that equation is that either the first variable is equal to 0 or the second one is equal to 0. In this case, the variables are the same again. So we get x plus 3 equals 0 and x plus 3 equals 0. So what we have from this case, we get x is minus 3. From this case, we also get x is minus 3. So what we have is a repeated root. So x is actually equals to minus 3. And you can just put repeated in a bracket to show that we have repeated roots. That means the root of this quadratic equation. So this quadratic equation has one root, and that root is x equals minus 3. When x is minus 3 in this equation, y becomes 0. Or rather, x equals minus 3 satisfies this equation, or this equation. There are many ways to think about it. But we're not worrying about the analytical approach. We're worrying about the graphical approach, which is very simple. Once you have a plot of a quadratic graph, you can identify its root by looking at the intersection, by looking at the x-coordinate of the intersection point of the quadratic graph with the x-axis. These are red. This red line represents, this red curve represents the quadratic equation here. It intersects with the x-axis at this point D. The x-coordinate of this point is actually minus 3. So you would have to plot this graph, and on your graph paper, determine the x-coordinate of the point of intersection. Here it's minus 3. Obviously, this is just a sketch, so this is not a proper graph. But we also determined it analytically and determined minus 3. So as an exercise, do this at home. Plot this graph. Actually, we've already plotted it, but plot it on graph paper. Determine the intersection of the quadratic curve you obtain with the x-axis, and you find that it is minus 3. And that is all. So I'll just reiterate. The root of a quadratic equation can be determined by identifying the x-coordinate of the point of intersection of the quadratic curve, the graph you plot, and the x-axis. So you're just looking for an intersection of the x-axis and the quadratic curve. At that intersection, you have a point. Read off the x-coordinate of that point, and you get a root. Now, you have some graphs where, I'm just going to draw another one, where you have a quadratic curve like this. Now, this curve intersects the x-axis at 2 points, here and here. You'll have to read off the x-coordinate at this point and the x-coordinate at this point to get 2 roots. So far, we only dealt with quadratic graphs that intersect the x-axis at 1 point. Here, this blue line represents the quadratic equation that intersects the x-axis at 2 points. All you have to do is just read off the x-coordinates. So in this case, it would be something like, say, x would be 3 here and here, x is probably minus 1. So in this case, your root would be x is equal to 3 and x is equal to minus 1. But one thing I can tell you is, if you have time, after determining your values graphically, you can also use the analytical approach to double check your answer, to test your answer. So what do I mean? I mean, you could get your result by reading off the x-coordinates of the point of intersection of the quadratic curve and the x-axis. And then you can test your answer by taking your quadratic equation, replacing y with 0, solving the equation you obtain, and checking that the x values you obtain via the calculation match with the x values you read off as the x-coordinate of the points or point of intersection of the quadratic curve and the x-axis. So many words here, but all we're just saying is read off an x-coordinate at a point of intersection. If there are 2 points of intersection, read off the 2 x-coordinates, and those are your roots. Very simple stuff. So do try at home to see if you can get the same answer, and see if you can get the same answer for the equation y equals x squared. And obviously you have your textbook, which you can use to try different exercises. Next, we're going to look at properties of graphs. Particular ones are the x-intercept and the y-intercept. And as the name suggests, the x-intercept of a graph is the point where that graph intersects the x-axis. So let's just start slowly. We have a graph here. We have a red line. This line is the plot of this linear equation, y equals minus 4x plus 16. So we have a graph here. Now this line crosses the y-axis somewhere. Crosses the y-axis. Let's see. Let's use color. Crosses the y-axis here at this point, and it crosses the x-axis at this point. Now the point where this line crosses the x-axis is known as the x-intercept of the line. The point where this line crosses the y-axis is known as the y-intercept. X-intercept, y-intercept. Simple stuff. Now, the x-intercept is given by as a point and has coordinates. In this case, it's 4, 0. In this case, it's 0, 16. So it's just a point, and when you have that point on your graph paper, you read off the coordinates. You read off the x-coordinate and the y-coordinate, and there you go. You have your x-intercept. Do it ditto for the y-intercept. So easy stuff. Now, when we plotted linear equations in the previous video, I just picked x value ranges randomly, and we just got the corresponding y values, and we just plotted our graph. Now I'm going to tell you one thing you have to add to your graph plotting. When you're plotting linear equations, make sure that you choose a range that is such that you can show the y-intercept and the x-intercept. So say you had some graphical axis, so you had an x and y axis like this, and you're plotting a straight line. And when you chose your x values and your y values, it was such that you only showed this line. So you didn't show an intersection with the y-axis and an intersection with the x-axis. You will then have to increase your range of x values, so you can have a point here, and you have to increase your range such that you also have a point here and point here, so that you can join them up, so you can actually show where this line intersects the y-axis and where it intersects the x-axis. Now, this kind of thing will take practice, but it's very simple concept. So my key point here of this video is that the x-intercept of a graph is its intersection with the x-axis, and you can just represent it by writing the coordinates of the point where the line intersects the x-axis. You can see this is a line and it intersects this line, the x-axis, at this point. This point has coordinates. Same thing here. This line intersects the y-axis, which is also a line, at this point. You can read off the coordinates of this point on your graph paper. And I've also said, when plotting linear equations, make sure to choose your x value ranges so that, or your x value range, so that you can show the x and y intercept. So you need to make the range wide enough so that you can show the intercept. And you need to practice. So I think the best way to learn this is to just choose some range randomly. You get this line and you find that, oh wait, I need to show where this intercept is. So you then increase your range till you get this point. You can get this point, so I'm saying till you get this point, this point. And with practice, you figure out for yourself how you can always ensure that you can show the x and y intercept when you plot linear equations. Now, if you don't like that trial and error approach, which I just suggested, where you just try choosing ranges and hope that the x and y intercept show, and if they don't, you just have to try a wider range, I have a shortcut technique for you. Now, given an equation, so this is a linear equation, so it's plotted as a straight line. I determine the coordinates of the x-intercept and the y-intercept without drawing anything. To determine the x-intercept, replace y with 0 in the equation. Why? Because the x-intercept is the intersection of a graph with the x-axis. X-axis. So this is the x-axis and this is the y-axis. And this is a line. This line intersects the x-axis at the x-intercept. Now, everywhere on the x-axis, y has a value of 0. Let me show you. So let's say, let's draw something bigger. So let's just focus on this. So assuming this is a line we have, some plot of some equation. This is its x-intercept. I'm telling you that, say we had calibrated the y-axis as follows. 1, there was a 2 here, so -1, there's a -2 here. You know the origin here is 0. You know that for a point here, the x-coordinate is something, but the y-coordinate is 0. For every point on the x-axis, the y-coordinate is 0, as you can see, because if you just move to the y-axis, you read off 0. This is something you've done in junior secondary, but I'm just making it clearer. For every point on the x-axis, the y-coordinate is 0. So in order to determine the x-intercept of an equation, just say, oh, when is y 0 on that graph? When is y 0? Y is 0 on this graph when it intersects with the x-axis, because this point here lies on this line. So let me extend the line, and let me use a different color for the point. This point here is the x-intercept, and it lies on this line. And it is such that it is the point where y is 0, because it's a point also on the x-axis. So you might need to review this again. But the simple rule is that to determine the x-intercept, replace y with 0 in the equation. In this case, our equation now is y equals 2x plus 1. If I replace y with 0, I get 0 equals 2x plus 1. Making x the subject of the formula, so I'm just swapping left and right side, left-hand side and right-hand side now. Making x the subject of the formula quickly gives x equals minus 1 over 2. So for this graph, the x-intercept is where x is minus 1 over 2, and of course where y is 0. That's why we replace y with 0, because we know that at the x-intercept y is 0. So these are the coordinates of the x-intercept for this equation. As for the y-intercept, to determine the y-intercept, you have to replace x with 0 in the equation. Why? Because let's look at this graph here. The y-intercept is here. And we know that on this y-axis, every point that lies on the y-axis has an x-coordinate of 0. Every point that lies on the y-axis has an x-coordinate of 0. So this point here, which lies on the line and also on the y-axis, because this line intersects the y-axis. So where they intersect is a point which lies on both lines. And that point, because it lies on the y-axis, it has an x-coordinate of 0. So the x-intercept of this line is the point which has an x-coordinate of 0. So determine the y-intercept. To determine the y-intercept, you have to replace x with 0 in the equation. So this is our equation here. Replacing x with 0 gives, let's do that here. Replacing x with 0 gives 2 times 0 plus 1. Y equals 2 times 0 is 0, y is 1. So we know that the y-intercept has coordinates 0 and 1. It has an x-coordinate of 0, y, because at the y-intercept, the x-coordinate of the point is 0, and we've determined the corresponding y value. So for this, we need practice. So here's an example question. It says, plot the graph of y equals minus 2x plus 20, clearly showing the x and y axis intersections. The x-axis intersection is the x-intercept. The y-axis intersection is the y-intercept. So we're going to determine them before even going to plot our graph. So the x-intercept, to determine the x-intercept, replace y with 0 in the equation. Doing so, we get y equals 0. So this is our equation. Y equals 0 minus 2x plus 20. I'm going to make x subject to formula. So if I'm going to add 2 to both sides. 2x, sorry, to both sides. So let's even do it this way, step by step. 0 plus 2x equals minus 2x plus 20 plus 2x. 0 plus 2x is 2x. I'm grouping like terms here. So I have 2x equals minus 2x plus 2x is 0 plus 20. 2x equals 20, x equals 10. So we know that at the x-intercept, the y-coordinate is 0. And now we determine the corresponding x value. The x-coordinate is 10. So all we had to do was replace y with 0 in the equation. That's all you need to remember. Simple. For the y-intercept, one just needs to replace x with 0 in the equation. So for the x-intercept, replace y with 0. For the y-intercept, replace x with 0. Very easy to remember. So replacing x with 0 in the equation, this is our equation here, gives y equals minus 2 times 0 plus 20. Gives y equals 0 plus 20, gives y equals 20. Therefore, the y-intercept of this equation has coordinates x 0 and y equals 20. The x coordinate is 0, which is why I replaced x with 0. Here, the y coordinate of the intercept was 0, which is why I replaced y with 0. So I've done the plotting for you. We expect to have an x-intercept of 10, 0. X-intercept. I'm going to call it x-int to shorten it. And a y-intercept of this. Now I plotted a graph. As you can see, the y-intercept, it's 0, has coordinates of 0 and 20. The x-intercept has coordinates of 10 and 0, as we expected. So I'm going to reiterate. You need to do the following when you want to determine an x-intercept. To determine an x-intercept, replace y with 0 in the equation. When you do that, you get a y value. Now, because you replace y with 0, x with 0, you know that the x coordinate of the y-intercept is 0, and the y value you obtain is the y coordinate. To determine an x-intercept, and replace y with 0 in the equation. And the x value you obtain is your x coordinate, and you know that your y coordinate is 0. So for the y-intercept, the x coordinate is always 0. For the x-intercept, the y coordinate is always 0. And by replacing x with 0 in an equation, you get its y coordinate of its intercept. By replacing y with 0 in an equation, you get the x coordinate of its x-intercept. So this thing takes practice to master. So here's another equation. Y equals 3x plus 11. We're going to determine its x-intercept. To determine the x-intercept, set y equals 0 in the equation. Doing so gives 0 equals 3x plus 11. I'm going to swap the left and right hand sides. Yeah, let's give 3x plus 11 equals 0. So I just interchange the left hand side and right hand side of this equation. I'm going to make x the subject of the formula. Therefore, the x coordinate, so this is how you represent intercepts. The x coordinate is minus 11 over 3 for the x-intercept. And the y coordinate is 0. So another way to also check if you've not mixed up x-intercept and y-intercept is to check that for the x-intercept, you always have an x coordinate, but you will not have a y coordinate value. For the y-intercept, for the x-intercept, you have an x coordinate value, and your y coordinate value will always be 0. For the y-intercept, your x coordinate value will be 0, while your y coordinate value will be anything else. So for the y-intercept of this equation, for y-intercept, check set x equals 0. Doing so here gives y equals 3 times 0, 0 plus 11, gives y equals 11. So the coordinates of this the y-intercept of this equation are as follows. X coordinate of 0, we set x equals 0, and a y coordinate of 11. And that's all. So this is your y-intercept here, and this is your x-intercept here. Here's another equation. Y equals 4x minus 10. To determine this x-intercept, set y to 0. Replace y with 0 in the equation. Doing so gives 0 equals, so that's a 0, equals 4x minus 10. I'm going to swap the left hand side and right hand side. I'm going to make x the subject of the formula to give x is 10 over 4, which is the same thing as 2 into 10, 5, 24, 2. So therefore, the x-intercept of this equation is 5 over 2 and y coordinate of 0. So it has an x coordinate of 5 over 2, x coordinate of 5 over 2, y coordinate of 0. But the y-intercept, we set x 0 in the equation, which gives a y value, the corresponding y value of 4 times 0 is 0 minus 10, because y is also minus 10. So the x coordinate of the y0 of the y-intercept is 0, and the y coordinate of the y-intercept is minus 10. So as you can see, to determine the x-intercept, set y as 0. To determine the y-intercept, set x as 0, and you're done. It's a simple thing. And when you have your graph, so I'm just going to sketch here. When you plot a graph for such an equation like y equals 4x minus 10, make sure you show the x and y intercepts. So this graph is going to be of this sort of form, something like when it's 0, it's going to be something like this. You need to make sure that you show these 2 points. So this point here would be the x-intercept because it's intersection with the x-axis, and that has coordinates of 5 over 2 and 0. 5 over 2 and 0. And here's our y-intercept, the intersection with the y-axis, which has a coordinate of 0 and minus 10. X coordinate of 0, y coordinate of minus 10. And you just label it. It gives a more complete graph.